Hi Year 9, welcome back to Science at British Online School. Today we are moving on to lesson 3 of our energy topic and we're going to be focusing on nuclear energy. For our starter task today, we've got a short quiz that we're all going to carry out. Now, a lot of people have preconceived ideas when it comes to nuclear power, nuclear energy and what that means. They think about the dramatic, the explosions, the accidents. This nuclear power trivia quiz is going to help assess how much you already really know about how a nuclear power plant works, some of the basic principles of nuclear power and its applications. Do not worry about what your score is. It's really just to give you a baseline of seeing how much you might already know or how much you really might not. And we're going to learn about today in our lesson. Now that you've done the fun trivia quiz, let's have a look through the answers and see how much you did or didn't know. So, what process does a nuclear reactor use to produce energy? The answer to that one is fission, and that's something that at this stage in Year 9 Science I wouldn't expect everybody to know, okay? But the word fission means splitting apart the nucleus of a heavy element. Now, we've learned all about elements in our chemistry topic earlier on, looking at atomic structure. So the nucleus can actually be split apart. That's dividing up the protons and neutrons into two or more smaller elements. That's called fission. Taking them apart, and that's typically used in a nuclear reactor. The opposite of fission is fusion, and that's an easier word to remember. Fusion means to fuse or to bring together two nuclei to make a heavier nuclei, but it's not so easily controlled, so it isn't used for nuclear reactors where we need to control the process to get the energy out. Bombs have used that process. That's not what we're going to be looking at today. A nuclear reactor produces what form of energy which can then be used to generate electricity? Just like virtually all power stations, traditional power stations work by heating something up, okay? And heating that up, they can use that heat to then run a steam turbine or warm up water, which is able to then generate electricity. It is actually a very simple process, and it's how our regular power stations work that we looked at last year. So this was more a history question than a science question, but it's good to link these together. The first nuclear reactor was built during World War II as part of the so-called Manhattan Project. Where was the first reactor actually built? And it was, in fact, useful bit of trivia for you, at the University of Chicago. Okay, there's lots of information given in the answers, and as you've read through those yourself doing the starter task, you'll have seen that. But let's move on to the next part. In addition to building atomic weapons, the military soon found another use for nuclear power. And on January 21st, 1954, the United States launched the first nuclear-powered submarine. What was the name of this famous ship? Okay, and the answer to that one was the Nilicious. And that's there with a good bit of information about that if you're interested in how it's used in submarines. But what we're focusing on in science is the use of nuclear power in generating electricity. And the world's first nuclear power plant to produce energy for civilian use using nuclear power was Russia. The first power plant was built in Obninsk in Russia, about 70 miles away from Moscow in the 50s, and it continued to operate for almost 48 years, but then was shut down and decommissioned in 2002. Although it's used in a few countries, nuclear power remains an insignificant factor in worldwide production of electricity. Actually, that's false. It's now the third leading source of electricity, just behind coal and actually hydroelectric power, which we've looked at when we looked at renewables last year. Over 30 countries supply part of their energy needs using nuclear-powered generators. It's quite likely that the country you live in, definitely if it's the UK and also a number of other countries, you'll find that nuclear power is likely to power some of the electricity coming into your home. The answer to question 7 might have surprised you that in the first quarter of the 21st century, the country that has the highest allowance or highest percentage of its electricity from nuclear power plants is in fact France, because it's a really high percentage, 78% of its electricity from nuclear power. So France are really ahead of a lot of countries with moving to nuclear power. Nuclear power has a history of being a very safe source of energy, but no technology is perfect. One of the world's worst nuclear incidents occurred in 1986 in what present-day country? Now, I was very young when this happened, and none of you would have been born, but it is likely that you have heard of the Chernobyl nuclear power plant, not least because in recent times some films and TV series have been made about it. It was in what is now the current-day Ukraine. At that time, it was part of the Soviet Union. We'll look at that in the extension towards the end of this lesson, for those of you who get there, but it's a really, really unusual event, and although it's often discussed and it was a terrible event, it was by a number of human failures and not following safety procedures, some poor reactor design and human error, as it says in the answers here. So we'll have a look at that later, but it is not something that you need to be concerned about by living in a country with nuclear power, because modern day risk assessments and safety protocols are of such an exceptional standard that nuclear power is not considered to be dangerous. So as we've said, nuclear power is safe, it's cheap, and the world supply of the fuel is plentiful. While it's not a renewable energy source, you need a very tiny quantities of nuclear fuel to make huge quantities of energy. So it's got plentiful supplies and is not considered a fossil fuel in the same way as coal, oil and gas, which will run out. But we're asked here in question 9, what is the single major factor that's limited the expansion of nuclear power as a source of electricity? And the answer to that is the disposal of the radioactive waste. The leftover materials from nuclear energy being created remain radioactive and dangerous for a very, very long time, so they cannot just be cannot just be thrown out like regular waste. They have to be, buried deep underground. They have to be in radiation-proof containers made from specific materials and buried very deep underground, and there's concerns they might contaminate the environment. So there are a lot of attempts to solve these problems, but it is a major obstacle to expansion of the nuclear power industry. And finally, we were asked which country had no commercial nuclear reactors producing energy by 2010, and the answer was Ireland. No nuclear power plants on the island of Ireland, including Northern Ireland, but many other countries are now considering going nuclear. Now that we've looked at that and understood what we know or don't know so far about nuclear energy and some maybe of our preconceptions, we're going to look at our learning objectives. Today we need to reflect on our prior knowledge. We've done quite a bit of that already with our starter task of types of energy. We're also going to know an example of energy stored as nuclear energy being transferred, and we're going to look at how nuclear energy typically is transferred to electrical energy via heat energy. This is our third lesson looking at energy stores and focusing this time on nuclear energy. As we discussed in the starter task, nuclear power is an alternative source of energy. It is not a renewable source of energy, which is a common misconception. It's an alternative source to traditional fossil fuels, and it can also be a source of controversy and debate because some people believe it's dangerous and we shouldn't be using it. There's been a lot of negative publicity based on previous disasters. For the first part of today's task, we are going to look at a case study of nuclear energy, the Baraka nuclear plant in the UAE. It only opened this year in April 2021. Some of you might know the region. I know this is the first example of nuclear energy being used in the Gulf. In your task, you have got 3 different links here which go into detail about how the nuclear power plant is being constructed and why this is so revolutionary in energy production in an area which needs vast quantities of energy due to a rapidly developing population. For the second part of the task, I'd then like you to read this really interesting article from the American Chemical Society, which discusses the issues surrounding nuclear power in a really balanced way. It looks at the positives and the negatives and allows you to try and draw your own conclusions about whether you believe nuclear energy to be a really beneficial alternative to traditional fossil fuels in order to provide for the energy needs of our planet. The final section of the material to review for today's task are looking at the nuclear power stations in the UK. Quite a large number of our learners will live in the UK, and will be aware that quite a large percentage of our electricity is generated, around 20% of our energy is generated by nuclear power stations. This diagram shown in the slides shows us the contributions of the main nuclear power stations in the UK and how they've been growing over the years. And by clicking on this link, you can explore and find out more information about each of those. So today's challenge, a debate. What's your opinion? You've researched, you've read about the many advantages and disadvantages of nuclear power and other alternatives. If you were a government leader, would you choose nuclear power as a solution to meeting your country and the world's energy needs, or would you prefer to choose another renewable energy resource to develop alternatively to nuclear energy? You should work in your team in your breakout rooms and discuss your ideas and opinions. Please make notes and be ready to share and justify your ideas and opinions with the class. For today's plenary, we're going to look at nuclear accidents. As I said at the beginning of the lesson, nuclear energy is usually very safe and reliable, particularly in the modern day, but there have been a very small number of accidents that have occurred. And of course, due to the severity of this, they've been heavily publicised. You've probably heard of Chernobyl. You may have heard of Fukushima or 3 Mile Island. I'd like you to work with your team again now to investigate what happened, and we'll have a class discussion to finish on this.